Alright, so this week we're doing analytic geometry, specifically ellipses, hyperbolas, and things like that. We're going to start with parabolas. So this is right here the general form of a parabola. So when you're given an equation and asked to graph it, it will generally benefit you to force whatever equation they give you into this form. So you want something like x, and there may or may not be a value. H, A, and K all stand for numbers. The x and y are the only things that should stay variables. So what you essentially want to have happen is you should have an x, and then there may or may not be a constant there. If there isn't, then that means that, of course, h is going to be 0. And then you're going to want to usually complete the square on this side so that you can force your y terms into this type of form. So for this one, we're going to take this side of the equation and we're going to complete the square for these first two terms here. So this is going to now be x equals y squared plus 4y plus something. And then we've still got our plus 2 out here. So if you're going to ask yourself, okay, what would complete this square? In other words, what number multiplied together twice would give us this 4y in the middle? So if you have a plus 2 here, then if we, oh, I'm sorry, it's actually plus 4. Silly me. I'm not quite awake yet. All right. It's going to be 2 times 2. So if this is plus 4 here, then we can factor this part into something that matches more closely this form. But whatever you do on this in here, you have to subtract on the outside, because otherwise your equation is not balanced and you've made a fundamental change to the problem, and that's not okay. So if we have this equation here, this factors into y plus 2 quantity squared. Right? If you were to multiply all this back out, you should get this original equation here. So, and then we're going to look at over here, so plus 2 and minus 4 would give us the minus 2. Now, there's one other adjustment we have to make, because we want this to be essentially by itself on this side of the equation. So we're going to move this plus 2 over here, so again, our final equation more closely matches what we're looking for up here. So if we add 2 to both sides, then I have x plus 2 equals y plus 2 quantity squared. All right, and then for this problem, that means that h, and again, these are minus signs, so if you have pluses, then you're essentially looking at the negative of whatever this number is. It's going to be the opposite. So if that's minus, if this is a minus sign, then h would be positive. Since that's a plus sign, h is going to be negative. So h is negative 2, and then k is also negative 2. And just like previous graphing, if you're given h and k, that represents the vertex of your graph. So if we go over to graphing, hold on just one moment. Okay, there's one other thing that I should have indicated here. First, it's the value for a. Now, since there isn't a constant out in front here, that means that a is 1. And a tells you whether or not the parabola opens to the left or opens to the right. So if it's positive, then it opens to the right. If it's negative, it opens to the left. So since this is positive, our parabola is going to open to the right. And these are sideways parabolas, as you'll see in just a moment. Okay, so if we go about graphing this, so the key thing to remember on this is that for any given x value, you're going to have 2 y values because it is a sideways parabola. So we know already that this point here is the vertex of our graph. So that is going to be at -2, -2. So that is the low end of our graph, and it's going to, since a was positive as we talked about, it's going to open in this direction. Now we just need to graph some additional points. So it makes sense, since the graph opens this way, that we're going to want to look at x values that are bigger than -2, because anything less than that is not going to be on our graph. So I'm going to look at -1, and I'll explain why I'm writing 2 of them, and then +1. Okay, so as I previously mentioned, your graph for any given x value is going to have 2 possible y values. So if we look at what we're given here, so we've got, if I plug in my -1 in for x, I would have -1 plus 2 equals y plus 2 quantity squared. So this of course simplifies to 1. So now you have to ask yourself, okay, what values for y make this true? So you can do this algebraically by taking the square root of both sides. So if you do that, you would have the square root, square root. So whenever you take the square root of something, however, when you take the square root of a number, that means that you're going to have a plus or minus 1, and that equals y plus 2. Because if you think about it, 1 squared gives you 1, and -1 squared also gives you 1. So that's the reason for this plus or minus. So now we go about solving for y. We would subtract 2 from both sides. So I would have on this side, if this is +1, then +1 minus 2 would be -1. And then if it was -1, -1 minus -2 would be, I'm sorry, -1 plus -2 would also be -3. So the point -1 has y values of -1 and -3. So if we go about and graph these, so at -1 I have a point here and a point here. Okay, and then if I repeat that process for 1, I'm going to get some uneven, meaning decimal values for these, because what will end up happening, if you plug in 1 for x here, you're going to have 1 plus 2, which is of course 3 on this side, and then if you take the square root of it, it's the square root of 3 is not a terminating decimal. So that's why we have these kind of funky looking things here, but you solve it in just the same way to find the 2 possible points for 1, and then obviously going to attempt to graph it. So at 1, it's going to be, again, this is kind of approximating about right there, and then I will have another point down here-ish. And then if I draw my graph, I have this nice looking sideways parabola, which is what they should look like. They should either be opening this way or opening the other direction. Please let me know if you have any questions.